Welcome to homework.
Okay, we've got butanal. And asked what happens when we react it with H2 on a metal catalyst. Maybe, let's say it's palladium is a common one. What happens? Well, hydrogen is a reducing agent, or hydrogen on a metal catalyst support is a reducing agent. So this will serve to reduce our butanal. Right? So it's slightly oxidized right now. This carbon has multiple bonds to oxygen. That's an oxidized carbon. If we reduce that carbon, we're essentially replacing those bonds to oxygen with bonds to hydrogen. Right? So that's the reduction of butanal via H2 over palladium. Okay, now let's continue. Now we've got sodium borohydride. Right? What is sodium borohydride? Is it a reducing agent? Is it a oxidizing agent? It is a reducing agent, but it's not as strong as H2 over palladium. So we won't get the totally reduced form. We won't get the alkane. What we get out is an alcohol. And maybe I can make this a little more clear. H2, that's where these hydrogens are coming from. Okay, sodium borohydride, maybe I could formalize this. Let's make this 3, and then we'll put a little right there. That's where, well, not that hydrogen, but that hydrogen basically. That's where that one's coming from. Okay, next up we've got Tollens reagent. Still in red for some reason. Let's go back to black. Tollens reagent. Remember what Tollens reagent is for? Typically, it's used to test for aldehydes. And Tollens reagent involves silver ion. And if that test is successful, that is, if the sugar is a reducing sugar, which means that sugar has an aldehyde functional group, as opposed to, or can also have a acetal instead of hemiacetal. That would be like the the ringed sugar form as opposed to the straight chain sugar form. Point is, if it sees an acetal or if it sees a aldehyde, this silver gets turned from silver ion to silver zero and deposits on the walls of whatever reaction vessel you're using for that. So this silver is going to get reduced from silver plus to silver zero, meaning your aldehyde is going to get oxidized. Right. So in fact, the product of an aldehyde reacting with Tollens reagent will be an oxidation reaction in which the I drew that backwards, so I don't want that to be extra confusing, but let's do this. There we go. Will be an oxidized aldehyde. If you oxidize an aldehyde, you add an OH and it becomes a carboxylic acid. So that's what Tollens reagent will do. It'll give you the carboxylic acid. Finally, we have potassium chromate in sulfuric acid, and that's also a strong oxidizing agent, right? Potassium chromate there, H2SO4. It's an oxidizing agent, so it will equally give you, just like Tollens reagent, it'll give you the carboxylic acid. Reduction, less strong reduction, technically less strong oxidation and even stronger oxidation, but you can't really tell the difference between these two when you're just reacting with an aldehyde. So in fact, in either case, you get the carboxylic acid.